Well, good evening, good afternoon, depending on what part of the world everybody is in, and thanks for joining us for the MAID 3.8.7 walkthrough with myself, Peter Lucas, who's the CMO at PHM, for those of you that don't know who we are. And you'll see also on stage with me is Andrew Thorne, who is the product director and product manager of MAID. So I won't spend too much time doing introductions simply because we've got a lot to get through and we do have quite a few people on this webinar today. I will just ask anybody that's got questions, you're quite free to drop those in the chat. Depending on timing and how we are going, we will either address those during the webinar, or we will do that at the end when we get a bit of time to address the questions one-on-one. I'll leave that to Andrew's discretion. Andrew, just want to shift across to the agenda and I'll run quickly through just what we'll cover today, and it'll start with basically the upgrades to the, because this release is a mixture of both new functionality and quite significant upgrades. So the first two upgrades that we'll cover off will be mission profile definition, functional hazard analysis that really brings us in line with ARP 4761A, and we'll show you, and happy to take questions on that if you want more detail. Model-based control measures and FAMICA, diagnostic testability. We will cover Zen title only briefly with a few screenshots. It's very difficult to show that. That's our licensing, our new licensing platform. And then we'll move across to talk briefly about the new integration and enriched integration APIs that MAID has now got present. And then the very last subject we will cover, which unfortunately will be in screenshots, is the Teamcenter integration, only because it is particularly difficult to demonstrate that in a live environment. So I won't take up too much more time other than say over to you, Andrew. And by all means, people, please put the questions in the chat when you are ready or got questions to ask. Thank you.
Thanks, Peter. So yeah, as Peter mentioned, we're proud to sort of present MAID 3.8.7. The whole release is kind of, I guess, primarily focused on a safety-based upgrade to functional hazard assessment with regards to ARP 4761 revision A. And also we have a bunch of generalist features, so revised criticality and model-based FAMICA, and diagnostics and testability and others. So without further ado, I'll take you through those. I'm going to flick through the software to really try to get to the guts of it and show you how each of these things work and explain them as I go. So the first one is the upgrades to the MPD section, the mission profile definition. So what we did here was the main reasoning was to upgrade these with regards to ARP 4761 revision A. So that sort of upcoming, I guess, release of the standard is focused on a bunch of elements that describe sort of flight phases and scenarios and things like that, and the use cases of your aircraft. And with this comes a few different features that are a bit different to what we had in the past. So we've got some specialized phases features, which are alternations or variations of mission phases or flight phases. We have sort of some upgrades to mission events from this previous special conditions element that we had. And we also have some expansional upgrades to a mission conditions feature. So I'll take you through the software to demonstrate that. So for this, I just need to open up the mission profile section of MAID, which I've done by clicking modeling. And I'm going to take you to a standard flight that I've got prepared in this demonstration model. So the first one here was the specialized phases portion. So normal flight phases and mission phases look like this, and they represent the sequence of actions that are occurring in your mission. Specialized phases are focused on, I guess, alternate phases of your mission or your flight that are planned to happen, but I suppose not part of the normal sequence. So these are kind of deviations, but they're sort of planned deviations. So putting these in there provides you with the ability to clearly define that additional context for those things that may occur in your mission, and things like reject takeoff or steep approaches in an aircraft sense. And with that, you've got all the general functionality that you've got with mission phases. So you can define new codes, names, durations and hours and descriptions along with those. And after you've also created those, what you can do is you can define them back to the mission phase that it occurred against. So this one here might be relevant to taxi or takeoff, that primary phase is there. And we're going to see a little bit more about this just next, but you can also associate some of these specialized phases to mission events, operational conditions, or environmental conditions to provide some sort of cross-connectivity there. So really the reason behind this is it just allows you to capture that extra context and things and phases that are going to be happening in your mission profile so that you can use it in your safety assessments and your FHAs for criticality assessment. One of the next ones that I mentioned before was mission conditions or operational conditions and environmental conditions. So previously what we did is we had environmental characteristics, and these were assigned to mission phases. Now what we've done is we've upgraded that concept. So your old environmental characteristics will upgrade into environmental conditions. And we've defined a new sort of taxonomy here, or at least data object, that represents the operational conditions. So these are procedures or elements or properties that are occurring during your different mission phases. So that might be waiting or loading of baggage or cleaning or something like that. And your environmental conditions are representing sort of aspects like humidity or temperature that are associated with your mission elements. So again, you can push the plus button and copy or delete to sort of create, copy or delete those elements. And beyond that, you can also give them a code, a name, a description, and again, you can associate back to the mission phases and segments of interest, or if it's a specialized phase, you can associate that linkage here. And last of all, you can also identify particular mission events that that might be associated with. Last but not least is the mission events section. So what we've done here is we've taken the previous special conditions section of the MPD, and we've upgraded this to better represent, I guess, what it was before, which is an event that occurs in your mission profile or your flight phases that has a specific sort of occurrence or rate, so it can be sort of predicted how often that might occur. And this is kind of something that gets external and generally outside of your control and not really planned for, but you're aware that it may occur. And this has different taxonomy types between operational and environment, and it represents things like weather-related conditions, tails and crosswinds, wet runway conditions, and things like that. So again, it captures that extra context, I suppose, that might be associated with your mission phases and flight phases. And with each of these, you can, again, give it a unique code, name, description, define its taxonomy type, and associate a certain rate that may sort of befit how often it's occurring. And also, you can sort of associate which mission phases or segments it may associate to, and if it itself has any particular operational environmental conditions that go along with it. So I guess to summarize, this whole section has been about, I guess, upgrading and making more explicit the different ways that you can capture and identify how your system of design is being used so that you can get a more enriched safety assessment. So the next section will take you through the functional hazard assessment. So there's quite a few changes here. We're going to start off with just the general layout, and then I'll take you through pretty much all the key steps and all the different things that we've updated along the way. So this one here is located in the functional diagram, and what I've got is a particular example down here, one layer deep on generate, distribute the hydraulic power. So this is the kind of the new layout that we've got in this upgrade. So there's a lot more tabs here, and there's a more streamlined, I guess, flow that's separated very clearly here, and it's fairly sequential. So you can follow this tab structure to go through the assessment process instead of a whole series of tabs along the bottom hand side there. So some of the basic elements that we have changed with the failure conditions are a few of these buttons here. So first of all, we've got this one here, which is called Associate Failure Conditions to the Function. This effectively allows you to portal another failure condition into this function And pretty much what this is doing is linking a previously identified failure condition to more than one function. So you can do this multiple times, and it just creates extra associations in the model. And the original assessment kind of sits on that original function there, provides safety integrity. Another one that we have that is kind of similar but not quite the same is this combined failure conditions feature. So a little bit similar, you choose two different failure conditions here, and it kind of bundles those together as a package and can show you what the different assessments here with those various failure conditions that I selected are. And what that can allow you to do is provide a different maybe assessment that is the result of those two things occurring together. So maybe the resulting criticality assessment is different and higher than what the individuals are together. So there's sort of two new options there that expand your capabilities to deal with and capture failure conditions that we've added. So now I'll take you through a lot of the basic tabs. So we've updated the mission profile section here with regards to the changes that I mentioned before. So what we've done here is kind of put the specialized phases alongside the mission sections, the mission phases and segments. So you can enable the specialized phases as well as the phases and segments here. And in the events and conditions section, we have separated this and sort of upgraded this to include the various mission conditions and the mission operational and environmental events. So you kind of got all the events and conditions here together to help specify those linkages between those events and conditions and your failure conditions for the assessment here to provide that context. And there's also a few sort of new filtering options here. So you've got a couple of different search bars that have been added in for ease of use. You can turn on and off filtering by the mission phases. So if something was linked to your phase before, that will sort of hide that by default, but you can turn that off. And there's another toggle here, which is quite important for the new Revision A standard, that allows you to specify whether your operating crew or past operating crew are actually aware of the failure condition. And that can drastically, I guess, provide context and change your criticality assessments. A completely new tab that we have over here is a safety criteria and hazards section. So what this allows you to do is, I guess, create and reference against a list of safety criteria or hazards to help you identify what the hazards and the resultant criticality may be for your failure conditions. So here I've already got two hazard criteria: aircraft control display and mission capabilities, and with them about 5 hazards each that I've already defined. So if I click on this cog here, what I can see is this is the sort of the new preferences area that we're using for the FHA, I guess, objects and material. And this here is a list of my safety criteria that I've already defined. And if I go ahead and sort of create a new one of those, you can see that I can give them IDs and names here. And beneath each safety criteria, you can define any number of hazards as well as the resultant criticality here. So effectively what this enables you to do is create, I guess, hazard libraries or folders that store your hazards. And with each hazard, you can sort of determine what the likely criticality of that event or hazardous situation is going to be and document that in sort of a library. And then when you're finished with that, you can bring that into this table here and look at those criticalities that may be standard to those situations, so that when you're giving it a criticality assessment later, you can have a consistent or standardized approach, so you won't be missing a potential sort of scenario that is, I guess, common or identified by your criteria or hazards. A new section that we have here, well, it's a bit more of an upgrade, I suppose, is the failure effects section. So previously what we had inside of MADE is we had a single narrative, which is the overall effect here. And this was used to capture sort of all of the different effects for the different flight phases and everything else. So we've done two things with this. We have created this customized, I guess, taxonomy section in the preferences. So that cog can take you here. And I've created 3 here for aircraft, the crew or the people operating it, and the occupants or the passengers. You can create sort of custom narratives there as you need. And this just allows you to get a bit more specificity and context that you might likely have to define with regards to some of these different criticality profiles. So you can see here what I've done is separated my assessments in this example at the top line for the effect on the aircraft, the crew, and the occupants. And what you can do in addition to this, but the level is actually under your control, is that you can define the different effects for both those custom narratives or the general overall effect. And you can do that for every single mission phase or segment. So if you wanted to get into more specificity with regards to a certain phase, then you can enter that against that phase. Or if you want to keep it more general, you can just leave it on the top line, and that will keep it close to the previous assessments. So you've got a lot more control and, I guess, customization that you can put into failure effects narratives if you wish. So one section that's largely unchanged, at least on the surface, is the criticality section. So this is pretty much the same that it was in the previous, I guess, build of Mate. But what has changed now is we have these 2 subtabs. So this represents the baseline or the initial criticality assessment. And beneath that, we have an ability to identify what control measures may be applied to your failure condition, which may allow you to revise or change your criticality assessments or probability target. So here what I've done is identify potential crew training or maintenance and inspection that may allow me to revise and change my criticality assessments. So this whole section is optional. You don't have to use it, but if you wanted to get this sort of capability, then you can go through and define that control measure and then edit your changed severity class and probability slider, and then effectively you end up with a baseline and a revised value for that FHA assessment outcome. So moving on, we've got another section that we have upgraded. So what we did here is we have kind of taken the whole annotation idea here and upgraded this into an assumptions feature. So this is something that's called out in the new standard as a safety assumption. And this can help you provide context behind any aspect of your assessment or just the general construction or creation of the failure condition itself. So you see here, I've got a few different assumptions about how the hydraulic loss without engines or the landing gear down without hydraulics is going to occur. And pretty much what you can do here is I can choose this cog to go to my assumptions section of the sort of the library and see all the different assumptions I have. So at any stage, you can kind of create one there, which means that it can be reused across different failure conditions. And once it's created, you can click that plus icon to sort of bring that into your assessment and have whatever properties were identified on it and that context assigned for that failure condition. And a similar idea here, what we have done is we've upgraded the verification methods feature of Mate into substantiation actions. So this is something that's talked about in the new revision A. And effectively, it allows you to substantiate the ways or methods that you might be using to validate or substantiate your failure conditions and assessments. What we've done here is just provided a couple of examples for FDA or for MICA, for example. And again, it's similar to the assumptions where you can click that cog and define your sort of substantiation actions taxonomy or library. And once you've done that, you can come back to your assessment and use those across multiple different failure conditions and bring that into the list. And another thing that you can do once you have brought that into the list is you can specify with each of those which assumption it associates to. So if you wanted to not just associate that with a failure condition and it had some impact or relationship to one of your assumptions, so maybe you're substantiating a particular assumption that you made, something about actually implementing a safety procedure or something like that, then you can click that to one of your assumptions and have that linkage across to your assumptions as well. So that about wraps that section up. From this point, I'll launch into some more generalist features, I suppose. So what we're going to be talking about here is what we've changed in regards to revised criticality and Formica. So this, I guess, section here is all about the control measures. So I've got this in my model on my landing gear system, and it's inside my rear wheel braking system. So I'm just going to navigate down to that level. And pretty much what we have done here is effectively replaced the detection methods and the compensating provisions that we had previously with a new taxonomy element for control measures. So if I go into the Feely diagram, you'll see that we've got these new yellow icons that should be taken over and carried across from your previous detection methods and compensating provisions. And if you right click where you normally had detection methods and compensating provisions, you now have control measures. So what you can see here is I've already got two defined control measures for code review and safety critical functional threat analysis. And each of those have a taxonomy type analysis and fail-safe designs. So what these are and what we've done essentially is we have upgraded the entire, I guess, taxonomy. So we still have the full taxonomy list that we previously had for compensating provisions and detection methods, like you can see here. But we've added in a completely new section focused on prevention controls, which is, I guess, a little bit more suited for design-based activities. And there's also another sort of subset or subsection for substantiation actions, which is what we were just looking at before. Now, on top of that, you can also create as many customized taxonomy sections and categories as you wish. So here I've got one called custom, and I'll show you about that in a little bit more detail. But I guess the point is here that what you would normally do to create one is similar to what we did before by choosing a taxonomy element, giving that a unique name if you wish, and then clicking add, and that will sort of add it to that particular element here. Now, that's not all. Another sort of main motivation or reason why we changed this is we wanted to better tie this into your Formicas or your revised criticality. So this barrier matrix that I clicked on here is essentially a visual representation of what you can do with deltas regarding to the control measures. So if you associate one or more control measures to your failing mode, what change in your criticalities I can have. So here I've got an 882E assessment method applied. So there's two different measures that I'm focused on, which is software control category and probability of occurrence. So on the left, you can see my revised number that I had set before. And with the two methods or three that I've now assigned, I can change the numbers on these to sort of revise it or reduce the criticality by a certain margin. And the end result is showed over on the right-hand side, which brings that down to a 4.0 or an improbable ranking based on my profile. So that's kind of the main impact, I suppose, of that section. And, you can see it a lot through your different Formica assessments and everything like that, which I will show you in just a little bit. But first of all, I'll show you the customization portion. So not only that, you can have full control over the custom taxonomy. So what I've done here is I've created a new category to store sort of a custom taxonomy. And you can create as many categories as you wish here by just selecting that button and typing some text in for the category name. As you say, it's created a new one. And within any given category, you can select the other button to control a new control measure. So you can pretty much go about this procedure to create a full sort of custom list and as many different categories as you need, and just use those as your, I guess, default control measures for your different designs or projects. And not only that, you can, export and import those different control measures. So that's sort of easy to share. And you can also apply that to your model. So just before I show you the Formica, I'll quickly try to run through the different changes to the criticality methods. So the revision A method's been tweaked slightly, but it's really only just a couple of name changes with regards to the standard. What we did over here is a few changes with regards to 882E. So previously this was hardware, so we had the probabilities and severity over here and the criticality in the risk assessment matrix. Now what we've done is sort of added the other side to that standard, which is the software categorization. So what you have now is the severity categories and the software control categories, which results in a SWCI level. And that is individually controlled based on your control and your severity categories. So essentially, the way that you will go about this is segmenting your model into the software and the hardware portions. And when you're assessing your software elements, you give them your control levels and your severities. And when you're assessing the hardware, you give that your probabilities and your severities. And then the calculations are done according to those matrices that you set up. And then when you get around to the stage of doing it for FMECA, then you choose your different sort of assessment for the different areas of the model. So I guess what we will do now is just run through a quick FMECA to have a look at the result of that revised criticality method. So that was in my landing gear system. I'm going to choose the wheel braking system and turn that to a component level analysis. And if I search for my shutoff valve, what you can see over here is essentially the results in that severity code category. So for this here, what you can see is I changed my probability levels from the frequent to the remote, and that is resulting in a high 1F sort of assessment going up to a serious 1C assessment. And that will be across pretty much all of the FMECA templates we updated for this release. So the last sort of demo section I'm going to show is the PHM module. So we're going to take you through, I guess, some of the enhancements and upgrades that we made for the diagnostics with regards to testability workflows and upgrading costs with regards to testability. So for this one, you have to be in the PHM module. So I'll just make sure I change that over. And then once I've done so, I'm going to open up a diagnostic analysis. But before I do that, I'll show you, I guess, some of the basic fields that we added in because we'll be looking at these through the assessment. So if I have a look at one of my energy flow sensors, the majority of the changes here were with regards to a testability workflow and upgrading the testability analysis, I guess, costs with our PHM and our sensors. So we have added a series of operational costs and testing costs, and a few more extra costs here. So I think there's the acquisition cost and detection cost and a few name changes. Not only that, but we've added in this section here where you can identify how many people or sort of equipment that might be associated with carrying out or like taking care or servicing a particular sensor. So all of this is going to feed through and enable us to, I guess, consider and filter and compare our sensor analyses with regards to testability specific costs as we go through that analysis process. So if I go back to my example over here and open that up, I can show a few of the locations that have specifically changed. So a bunch of the, I guess, core tabs have pretty much stayed the same. So what has changed is the sensor parameters and I guess the aspects that regard to the costs. So here what we've got is the sensor parameters. So not only can you identify what those are in the sensor library, you can also do that in the sensor parameters section of the diagnostic analysis. And you can also freely enter the personnel and the equipment over in this section. Another tab that we've changed is the metric optimization. So what we have is this sort of cog option in the top-hand corner, and that allows you to sort of enable or disable those new metrics, as many as you wish. And that gives you sort of extra columns in your analysis that you can choose to sort of filter by, compare by, and then down select your PHM analysis by. So it gives you better control, visibility, and down selection in your sensor sets as you go through the standard PHM process with regards to testability. And last but not least, we also have included this into the charting aspects. So again, we've got that cog option that can turn this on or off, but it allows you to, I guess, compare directly the different testability costs that we have included. So the new operational cost, the testing cost sum, and use that as a metric that allows you to sort of trim down and compare those final sensor set options. So you make sure you consider those testability costs into your analysis. Okay, so now is probably a good time to, I guess, stop and pause and answer any questions if we've received any. So I'm just looking at the chat, and the chat is pretty empty at this stage, unless I'm missing something. So I think I encourage, if people haven't dropped any questions in the chat or have a question that they would like to ask, now's a really good time to do so. Otherwise, there will be a second chance at the end of the presentation to answer questions. So we're more than happy to do that.
I think we're pretty good on the questions, Andrew. I don't think there's any that have come through that I can see.
All right. Okay, so just a brief mention on Zentitle. So we have upgraded Zentitle in this latest release. What we've done is sort of completed it, I guess. So before it was missing the ability to run in complete offline or dark mode, so you wouldn't be able to use that when you didn't have an internet access. So we've been listening to our customers there, and that's obviously quite important for a lot of you. So we've included that capability. So now Zentitle is kind of fully equipped to replace Flex as our main licensing platform. So PHM will be only supplying Zentitle licensing going forward. We're trying to sort of consolidate that onto one platform. Next up is the integration portion. So as Peter mentioned before, this content is pretty hard to demonstrate in a live demonstration, but we will likely have some more opportunities to have webinars or discussions about this in the future, and I'll go into a bit more detail. So what I've done here is I've captured as much of the sort of starting point, the middle, and the end point of these integrations as possible, and sort of put this on the screen for us, and then I'm going to talk you through the different, I guess, what we've changed, how it works briefly. So here, the integration APIs. So we've got a lot of these different integration APIs, which are sort of the generic API protocols for MADE that are freely available and sort of public. And these allow us and any integration partners to freely connect to MADE APIs and connect this to any tool of your choosing. So really, it just depends on, does that tool have the information, enough information to provide to MADE, and does it have enough, I guess, to store all of the information that MADE is providing. So we've been advancing in this section of MADE. One of those areas that we have added in, which is a bit exciting, is the import and synchronization feature for functions and flows. So previously, we just had the system model block for your MADE model, which gave you the general hierarchy. Now we can essentially import all of the function and flow information to create a full, complete MADE model. If the tool or database that is providing that information has the required information. So does it have the inputs, the outflows, the internal connections? Does it have the taxonomy defined? Does it have the functions, and so on? So provided we're able to get that kind of information out of the tool, then we're able to map it to Made. And if it doesn't have information, then we just don't get those bits and pieces. But essentially, this gives you the capability to fully create a Made system model, functional model. And you can access that by using the API integration wizard and selecting that new functions resource. So another new analysis that we've added in is this functional fault tree analysis export. So this here is another analysis output. So we can store all this information into a database or another tool of your choosing. And this captures the functional FTA section of Made. So pretty much what it does is your entire FTA, all of the data, the top events, the intermediate events, the basic events, the probabilities, pretty much everything that's contained inside that fault tree analysis, you can export that into our APIs in a JSON format, and that can be passed into a database or a tool of your choosing. So this allows you to sort of, carry across and document that information. And that can be now selected in the analysis API, wizard. And you can see the fault tree analysis is the option to choose for that. Similar to the previous one, we've also done the same thing with hardware fault trees. So we haven't left this behind. It's the same kind of structure, I suppose. So it takes everything that's contained in your hardware fault tree analysis, all of the top events, intermediate events, basic events, the reliability values that go into that, power that, as well as the reliability groupings. And you can click and, enable that by doing the same thing, which is clicking fault tree analysis in the analysis API section. And then once you've done that afterwards, you get an ability to choose between your hardware fault tree and your functional fault tree and choose which ones you want to export. And the end result of that, again, will be a JSON format that contains all of that information from your hardware fault tree. And last but not least, the next major change, I guess, that we made with the APIs this release is the technical budgeting section. So this already exists in the import-export, the export items section of Made. And what we've done is we've contained that whole technical budgeting section into that items area. So here, technical budgeting refers to when you're assigning cost, height, lengths in a technical budgeting analysis, which carries from technical budget set to, say, the system level and a portion down to every single item in your model. So if you go through the export wizard and select items, you will be able to include all of that inside your item APIs. And there will be a new section in that called technical properties, which will contain all that information. So the next section is the Teamcenter integration. So we've been putting a lot of effort and work into this around about over the last year, and I'm proud to announce that this is officially sort of released. So I'll take you through, some of the key changes associated with this. So first of all, we've upgraded this with new Active Workspace and Teamcenter versions, and it's using a whole new sort of version of the MBSE gateway, which is the sort of the mechanism that it connects through in Teamcenter. So this is up to date with Active Workspace 6.1.1 and Teamcenter 4.1. And what we did as part of this project is we aimed to deliver more information and save that inside Teamcenter, so you have a bit more of a dynamic experience focused on some high-level safety analysis use cases. So we've taken what we already had sort of for functions and components, and we've added in a completely new section and custom template data model for mission profiles, mission phases, mission events, environmental operational conditions. So that allows an entirely new section that allows you to capture all of your mission-related data and properties, including all the linkages between that, so that all those links we're creating before are captured. And in addition to that, we also have elements for failure conditions, safety assumptions, substantiation actions. And again, we've got all the cross linkages there. So all of the context that is captured between your failure conditions through to your missions can again now be sort of exported into Teamcenter to facilitate a FHA review process or any sort of similar process to that. You can store it into Teamcenter, add commentary to it, push it out to review, version it, release it, and all of that good capability that Teamcenter brings to the table. So now I'll take you through, I guess, some of the screenshots and what it looks like and what it does. So the Teamcenter integration still allows you to, I guess, import. So previously we had functions and system blocks. We've sort of refocused the functions element and added this into our FHA section. So now what you can do is you can take system function elements from Teamcenter and you can bring those across and bring that entire hierarchy and map that across into Made. You'll get your entire Teamcenter sort of functional tree or structure. And that's useful later on because you can also sync with that structure and use that to, I guess, drive your FHA process. In addition to that, one of the basic outputs from Made to Teamcenter is the ability to export the item structure, the contents of the FHA, and the MPD data that I mentioned before. So in this example, what I'm showing is here's an FHA that I created, and I've got a whole series of different failure conditions and assessment links and things between those. You go through sort of an export wizard, reusing sort of elements of the APIs, and then you can export that into Teamcenter. So what you can see here is a summary level table that's got the same information that was over there, and it contains all of that information. There's linkages between the failure conditions and the functions, the mission phases, the events, and there's even some more properties along that table. And that whole process follows through for all of those mission phase sections, the safety assumptions and everything else. So all of those, the links that are created inside of Made is carried across into Teamcenter for your review process. So a highly sought after feature that we listened to and implemented and was able to bring across from our integration APIs and editor is a synchronization feature. So with all of the import use cases in Teamcenter for items and functions, what you can do now is keep that synchronized at the click of a button. So whenever you click the synchronize button in the Teamcenter Active Workspace menu, basically Made can go fetch the latest data and present that to you in this format, allowing you to go through the individual changes and filter this using our synchronization editor. Or if you want, you can just approve everything and push it into your model, but it gives you that level of visibility and control before you go and apply this into your safety or your Made model, and can help keep that up to date just at the click of a button. And this is almost, I guess, more important feature than the export. So once you've created that first original export into Teamcenter, from that point forwards, what we typically use in the integration is the update feature. So this update feature allows you to, what you can see here is any changes that you make in the model, you can click that update feature and that will push more data across into Teamcenter. And any basic changes that you have will be copied and pushed across into those data objects. So here you can see a couple of the different failure effect narratives and things. I added some 4s, some 1s into the name. I pushed the update button and everything was pushed across into Made. So the idea there is, you perform your assessments, you go through, make some changes, update the data across into Teamcenter, go through a review process. You come back, you might have a few more edits, you go through, quickly update a few things, maybe add a few more conditions. Click update, and it's going to push all that information across and add it to the previous set. Okay, so that's sort of the main capabilities of Teamcenter, and it pretty much wraps up the full sort of walkthrough. So we do have more detailed release notes available on the website. This kind of takes you through line by line on the specific changes. So it'll take you through things like what were the specific updates to some of the minor API sections, some of the specific customer requests that maybe I didn't have the time to go over today. So I advise you to have a look at that information if you get the time. And now I'll just briefly walk us through sort of not really a timeline, but just, what is PHM working on right now and what are we planning on next? So a lot of this is quite aligned with what we had planned to do in the past, but as time goes on, we've sort of reshuffled a few things. So we do and have planned a few different minor upgrades to Made Teamcenter. So there's going to be another sort of public release It's primarily just going to be sort of a few things that were slipped from the main release, some bug fixes and enhancements. So in about a month or so time, we'll have sort of another formal release for that, a public release that's focused on the main Teamcenter build. Beyond that, we are also actively working on right now the capability to import an FHA. So what we're looking to do here is effectively allow FHA and ARP users to bring in our Excel import feature and to bring in any FHA data that's in an Excel from another tool or a manual process and put that straight into Main so you can get up running and start using Main to do your model-based assessment. Another thing we're looking at alongside that is an RCM feature. So we've already got an RCM feature, but what we're looking to do is make that a bit more open and customizable. So not just a classic RCM2 methodology. We want to have multiple different processes and workflows supported, and effectively update and bring us to some new ideas and aspects of the model-based approach to that upgrade. In addition to that, we're also looking at modeling enhancements. So we've been listening to our customers and collated a nice list of things that will make it a lot faster and easier to use and perform modeling. So we're going to have an entire epic dedicated to making connections easier to connect, some automated features, and just a whole series of enhancements focused on making modeling easier and faster. Alongside that, we're also already started work on specification and sort of development planning for Failure RBD. So Failure RBD is essentially a next layer down from our typical block diagram reliability analysis. So this is going to effectively allow you to toggle an option to go down to the failure level so that you can apportion your probability distributions and everything down to the failure level if you choose. But also have much more visibility and control over the different reliability values calculated for each individual failure. And what this is going to mean is that we've got a separate, failure-based reliability analysis that allows you to do things like tag certain failures with certain properties and provide certain filters on your reliability calculation so you can sort of focus on a particular, maybe critical failure reliability or things like that. So it's going to give you a lot more depth and control in your reliability and will help tie into things like RCM and other analyses. The next big step from that, and one that we're quite excited about and actively planning, is a major platform upgrade. So we know that features such as concurrent users, server-based operations, and sort of better version control and historic, baselining of data inside of Main is quite important to people. So we're looking at upgrading the whole Main platform so that we can get access to some of those capabilities and perform some of those features. So alongside that, what we're going to try to do is implement a hazards prototype build that we've been looking at for some time and work that into the new platform upgrade. And a little bit later than that, might be a bit far in the future, but we're still working on, we've got a prototype for a discrete event simulation reliability tool. So that itself is kind of a new product. So we're looking at productizing that. So that's something to keep your eye out for. And last but not least, a model-based upgrade. So this one's a little bit different to the previous one that I just mentioned. What we're hoping to achieve here is to drastically upgrade the modeling capabilities. So we've called this Model-Based Safety Analysis Plus. Really what this is talking about is adding a different extra propagation or modeling technique that can allow us to do more fancy things like applying logic between our blocks, restricting certain conditions or behaviors, applying gates to our models, and generally just better integrating our fault tree assessments and our model. So you've got a two-way dynamic interaction between them. So that's another thing that we're really excited to start looking into, and I think will make a big improvement to a lot of our users. Okay. So that is probably a good time to stop and see if anyone else has some questions for us.
I'll just bring your attention to Toby's question, Andrew.
Mm-hmm. So the question there is there a capacity to capture the failure conditions of the operator, e.g. fatigued, And is there a capacity to include the operator as a system component for the hazard analysis? So I guess this is talking about the human factors, I suppose, capturing the failure conditions of the operator and including that as a component or context for the hazard analysis. So I guess the mission events and conditions wouldn't really apply to that so much. I suppose you could use mission events to capture the behavior. If you're looking at maybe more discreetly capturing the human factor, like a person is fatigued and that's going to happen at a certain rate, I suppose you could use that mission event. Maybe you could also use assumptions, but we sort of don't have a separate, I guess, human factors object or something in that hazard analysis at this stage. So that's maybe something that we could look into. It'd be interesting to hear a little bit more about that and maybe whether that's a sort of if that's coming from an 882E perspective or an ARP approach. But yeah, so I think my suggestion would be to either use assumptions or mission events to kind of capture those, because you can represent some of those situations, and the mission events themselves do have probabilities too. So if you know that your human factors or people are getting sort of fatigued at a certain rate, and that's going to have implications across many mission phases and conditions, and you can definitely use one of those elements to capture that. Okay, and it looks like there's... Did that help answer your question? If you would like a follow-up, I'm happy to sort of go on about that a little bit more. Okay.
There was another question there too, Andrew, just for your reference.
Okay. Yes, in the question section. Will there be a future capacity to pull in the model structure from a system diagram, e.g. from SolidWorks, system diagram from SolidWorks, even just to identify components? Okay. So I guess the question there is about what the definition of the system diagram is. I assume by system diagram you mean a system diagram that is based on a series of blocks that's connected in a diagram in SolidWorks. So that itself must have a structure behind it. Basically, my answer to this is, I guess there's no out-of-the-box connection that we have through Teamcenter, or the API, since they're sort of, I guess, open source or available APIs for many different purposes to connect to SolidWorks. But any tool that can connect through our APIs is a potential to be connected to the model. So as long as we've got the APIs available, we can do that. So if that means you would like to take a bill of materials structure that represents a system diagram from SolidWorks, and SolidWorks has its own APIs, which most tools do, all we need to do is engage with, say, a customer or a project with an integration partner, and then we can map that or many other tools to provide and connect to our APIs. So in that use case, yeah, we could look at a project or a connector that takes information from SolidWorks, maps that to our APIs, and then builds some structure in our system model. Okay, sounds like that. A bomb system model. Sounds like that has answered that question. Yeah, so I guess we've probably got a couple of minutes left. So if anyone's got any last-minute burning questions, I think now's the time to sort of ask them. I'm more than happy to keep answering questions. We've got a few minutes left. But I'm pretty sure Peter will probably be asking me to point our attention to the poll. So we are keen to get your feedback on, are there any sort of particular topics that you're interested in hearing about in the future, because we're keen to have similar webinar sessions, but on different topics, maybe certain features or functionality of Made. So you should see a poll popping up. So please choose any of these that interest you. So you can choose more than one and then select submit vote. And we will collect that feedback and use that to start consideration for planning future sessions. Okay, so it looks like can't see anyone typing anymore. It's probably pretty busy on that.
Yeah, I think we might call it, Andrew.
Okay.
Have you got anything else that you particularly want to cover off, or are we good to close this session off?
No, that pretty much brings us towards the end.
Okay, well, I'd like to just thank those people that took the time out of their day, some of them later in the evening and some of them early in the morning, to attend the session on 3.8.7. It will be something that we do now moving forward quite commonly for larger releases. That does not preclude you from reaching out directly to the PHM team, in particular Andrew, or anyone of his team to discuss or ask questions in relation to the release. We'd encourage that. We're a pretty hands-on team, and we always love chatting with our clients. So look out for the next webinar. It's probably be around model-based RAMs, or I'd say digital RAMs twin. I just want to thank Andrew for his time, and thank you all for attending. And all the best for the start of your day, and sweet dreams for those at the end of the day. Thank you.
Thanks, everyone.